Hello and welcome to FEM Expert. Today we will present you a basic tutorial continuing on our series in which we will show you how to analyze and model and analyze a volume model T-junction in Ansys. First, the junction that we will simulate is very similar to the one that we simulated with a shell type element, and it will be a T-junction with a transversal and longitudinal beam. The transversal beam will have a square rectangular profile of 40 by 60 with a thickness of 3 millimeters, and it will be embedded at the ends. The longitudinal beam will be a 40 by 40 by 3 millimeters profile, and in this tutorial we will use a couple of more interesting modeling methodologies like the extrusion of volumes, the reflecting of entities, and two different methodologies to bind two volumes. So as we mentioned before, there's going to be two methodologies from one point. So what you need to do is to give your Ansys instance a good name. I'm going to show it to you here. Just go to select your working directory and put the right job name, because we're going to save a model and resume it. So now we'll start with Ansys. As we did in the case of the shell models, what we'll do now is going to go and create the profile for the transversal beam. In order to do that, we're going to have to go to preprocessor. We're going to go to modeling, create, areas, rectangle, and by dimensions. So we're going to be the first dimension of the external square is going to be 0, 40 divided by 1000, sorry, here is 60 divided by 1000, and 0, 40 divided by 1000. We hit apply. What we'll obtain will be the 60 by 40 whole rectangular profile. Now we're going to create the inside square that we're going to subtract from this profile. So it's going to be a 3 divided by 1000. Here is 57. And 3 divided by 1000. And here is 37. We have created this, and we have these two areas. There's two areas here. We can, to look at them, we can list them, a list, comma, peak, and as you'll see, there's two areas. What we want to do right now is go to the operate booleans, and we want to overlap these areas. So we're going to go to overlap, going to select these both areas, click OK, and now what we have here, if we go to area list, comma, peak, is we have an internal area and an external area. We don't want the internal area, we want just the external area. So we're going to go to delete areas and below, and be careful to select the right one. We want this one. Okay. So now we have the rectangular profile. If we look at the oblique view or the isometric view, we just have this profile that we're going to extrude. In the last tutorial we extruded on both sides. On this tutorial we're just going to extrude halfways, and we're going to work with this halfway extrusion. Okay. So in order to do the extrusion, we want to copy a key point. Oh no, actually with the areas we don't even need to copy the key point and use the lines. We're just going to go to operate, extrude, areas, and here you can do it by X, Y, or Z offset. So we're going to go on X, Y, or Z offset, select this area, apply, and it's going to be on 0.5 meters along the Z axis. If we look now at the profile, we got the right profile with the right dimensions, and now we have to perform the same thing, do the same thing with the other profiles. Keep in mind that while working with this model, that we have just half model. So for right now, we're gonna go and we're gonna do the next thing. We're gonna go to Workplane, offset the workplane to key points. I'm gonna go to that key point, and we're gonna go to workplane, offset workplane by increment, and we're gonna rotate it along its y-axis 90 degrees. There we go. Okay. And now, actually, we'll go to make it easier. Go and offset the workplane by increments. We're gonna go do it that way, so we have the positive x and the positive y on the right direction. So now we have to do the same thing. We're gonna create an area, and we're gonna create the internal area. So we're gonna have the profile of the tube, the tubular profile. In order to do that, we're going to use a similar approach. We just have to think a little bit more, because here, let's go to create areas by dimensions. The first dimensions are 0, 0, and 0. And the second dimension on the x direction is 30, because we only have half of the profile. And on the second dimension here, it will be 40, and this one would be the same because we're not working on a quarter, we're just working on half of the model. We apply, and there we go, we have half of the profile. We can go here and plot. We can do a G-plot, hopefully it will be visible. It's not totally visible, you can see that there's another area here, you know where it is, or we can go to plot and plot areas. Okay, so for the internal rectangle, we're gonna have to do from here to here. We're gonna have to, or do it this way, we're gonna have 57 divided by 2, which is 2, so here it would be 2000, and it starts at 0 because we're on the middle frame. And for the y direction, we need 3 divided by 1000 up to 37 divided by 1000. We hit OK, and we can see that it's not quite, it seems to not be quite as good as we needed it. We can do we can delete it and do it again. So we're gonna do that right now. I'm gonna delete areas and below. I'm gonna select this one and hit OK. Okay, the little mistake that I made, we're gonna go again to create by dimensions, and it's 54 divided by 2000. Hit OK, and there we go. We have the rectangular profile. We're gonna visualize in order to visualize the areas better, we're gonna go to plot controls, numbering, and activate the areas. And now we're gonna see them with different colors and different lines. Also, we see the numbers. Well, what we want to do here is overlap these two areas, do the same procedure that we did before with the other profile. So to do that, we're gonna go to operate, booleans, overlap areas, and we're gonna select these two areas. We're gonna click OK, and again we're gonna go and delete the internal area. Okay, at this point we have this area and we have the volume. At this moment I'm gonna do something that we haven't done at all until now. I'm gonna go and click on save, so we can retrieve this model at any point and keep working with it. And I'm gonna show you a couple of things. The first thing is we're gonna show you two methodologies to do this, because for example, if you go and we do the same operation that we just did with booleans overlap volume or areas, and you try to overlap this area with this area, it will say it has been done, but it won't do it the right way. If you can kind of see, actually if you go here, there's two areas they appear in the same place, 11 and 4, and that is not correct. If you do an area list comma pick, you'll see there's more than one area in these regions, and that cannot be that way. Actually, in fact, this area 11 goes up to the end, so this model won't work. Okay, so we're gonna go to resume, plot areas again, and there's two methodologies. The first one will be extruding this half profile the same way we did, which is gonna be, we're gonna do it now. We're gonna be to extrude areas by X, Y, Z offset, and we're gonna extrude it by X, in the X direction 1 meter. And there we have the two volumes, they're just halves. What we're going to do now is plot areas. We are going to glue on the booleans, we're going to glue volumes. I'm going to go this volume with this volume, hit OK. And if you go to area list, you do an A list, comma pick, you'll see that there is, I'll go back more, area list, comma pick, you'll see that one of the volume ends up there, the second one ends up there, and the third one, so they're complementary volumes. We can actually go and plot the volumes, the areas, and you'll see that it looks pretty much fine because this blue volume doesn't go all the way through here. You can deselect, unselect, or select stuff to try to look at it properly, but we're not going to do that because already this tutorial will be pretty long, so we're going to continue with the model. So I'm going to go on plot volumes, and since we're working with half the model, we're going to show you how to, well, first of all, I'm going to go to plot controls, numbering, and deactivate the array numbering. And now, since we've been working, we work with half of the model, I'm going to show you how to reflect this model and obtain a whole complete model. So I'm going to do that. You got to go to booleans, no, sorry, not on booleans. It's under reflect here, down here. So we go to reflect, volumes, select these two volumes, and then the symmetry volume command will ask you along which axis, or along by which plane. So we have XY, we need XY, the Z plane, and when you do this operation, I'm gonna hit cancel. When you do this operation, you have to do it either in the local, in the origin, the global system, or you can change and do it in the local coordinate system of the workplane, but you have to be careful how do you position the workplane to do this thing. So we're going to do it, we're going to do a reflect along the XY direction, which is going to do it like that and have the proper way the reflection. So again, we go to volumes, we're going to pick all XY, we're going to do the volumes and mesh, and we're going to make it copied. Okay, and there we have the whole junction model. Once, as we said before, with all of the extrusion and all of these modeling operations, we recommend to do the numbering controls and go to merge items and do the key point merging, so you avoid having a double line in the middle or things like that. So at this point, we're gonna have we have the model, and we're gonna continue with the regular with the regular modeling process. So we're gonna go to element types, add the delete, add. We're gonna do a solid 185. Okay, we're gonna close. Go to material properties, material models, structural, linear, elastic, isotropic, steel 2.111, E11, Young's modulus 0.3, Poisson's coefficient. We're not going to put any density because we're not going to use any weight or any influence of the weight. Then, because we're using volume type elements, the next thing is to go to the meshing, and we're gonna go to size control, manual size, global size, and we're gonna choose a size of, it has to be at most equal to the thickness of the profile. So it has to be a size of 3 millimeters on all of the junction. And then we're gonna go to the mesh, and we're gonna sweep volumes because these structures are good to be swept. Then we're gonna sweep pickle. We wait a little bit, and then we will zoom in, and as you'll see, we got a really high quality meshing. Gonna go to plot and gonna plot volumes only, because otherwise it's gonna be really hard on the graphics. And I'm going to apply the boundary conditions, apply the forces, and simulate the model. So we're gonna go to solution, analysis type. As we know, the default one is static, so you can jump this step. We're gonna go to define loads, apply structural displacement on areas. We're gonna select this area and this area. Hit OK, all degrees of freedom. We select 0, and there we have the restrictions. Then we're gonna have input force and moments on key points, that key point and that key point. Hit OK. On the y direction, minus 1000 newtons. Doesn't matter the value, just so you can simulate the model. We go now to solver, current ls, hit OK. We have to wait for the solution. As you see, there's many more elements, so the solution takes a little bit longer than the other ones. When the solution is done, as you shall go to general processing, read results, last set, plot results, contour plot nodal solution, degrees of freedom solution, displacement vector summation. And as you can see, we have the displacement of the beam. The transversal beam has some displacement. We can actually go to the vector plot, the predefined, look at the translation. As in the other cases, it's similar. We'll see if we can see the rotation, but I'm not sure we'll be able to. No, the rotation is not a degree of freedom on volumes. Okay, I'm gonna go. I'm just gonna go and do again a contour plot nodal solution. I'm gonna show you the von Mises stress. Von Mises stress. And here, as you'll see, one of the very important things, I'm gonna go to the working plane and click it not to be selected, is the continuity. One of the very important things of these models is it's complicated sometimes to be sure if your structure has been connected with volume type elements. But as you can see here, there's continuity. It makes sense, all of these tensions make sense, and they go from here to here in the same manner. There's no discontinuities on the stress. So this is the first way we propose to model this, and then we're going to show you another way to do it. So you can take a little break of a second, and we'll go back to working with the model. I'm going to go to finish first, and then resume, and we're gonna start again with the model where we left it, where we had the areas, sorry for all that, we had the areas and the volume. The other methodology to do this is using the working plane and creating cuts, as we see in another tutorial before. So what we're gonna do is put the working plane to this key point. So we want to make sure that all the regions that we're using are connected to the volume. So we're gonna offset that there. We're gonna, okay, we have the working plane offset to this key point, and what we're gonna do is go to preprocessor modeling, operate booleans, divide volume by workplane. We're gonna pick all, and it's gonna make a little cut in this volume along the line in this position. We're gonna move the workplane to the second key point, and we're gonna do the same thing again on this volume. We can do again the plot areas. As we told you before with these things, is very good to do the merging items every time you do these operations, so you don't have double lines and things like that. Now we're gonna rotate the XY plane here, so we're gonna cut it this way, longwise too. In order to do that, I have to rotate. We have to rotate the plane along the x-axis 90 degrees, along the x-axis. So we have XY tilted. We'll do the same modeling volume by working plane. We're gonna pick all, so we don't have any problems. We go again to numbering, merge items, okay. And again, we're gonna go to working plane, offset to key point. We're gonna offset here. And we'll finally do the last cut, volume by working plane. We're gonna pick all. Then we're gonna do again the merging. The merging has to be done as the most the better, because sometimes when you do too many operations, then you won't be able to do any mergings. We're gonna check some things here. We're gonna check if, for example, we can area list, a list, comma p, and we'll see that basically there's just enough areas for us for the profile. So by doing this, which takes more time and it's a little bit more complicated, you are completely sure that these areas belong to these volumes and they are completely linked to each other. There's no way these areas are not linked to each other. So what we'll do now is going to modeling, operate, and we're going to extrude by the XYZ this area with that area with that area. Maybe we can try to do a loop. We'll see if the loop works. No, it doesn't work the way we want it, so we'll do it again, selecting this area, the second, the third, the fourth, and this fifth area. We're going to extrude them on the X direction at 1 meter. Okay, now we go back, we look at it. It looks pretty good. I'm gonna go and take the numbering away. The controls numbering off. And the model looks pretty good. As I said before, every time you do these kind of operations, well, the meshing, the extruding this or extruding that, but when we'll do the reflect, we'll have to do it. And now the next step is doing the same things that we did before with the model. So we're gonna go to modeling, reflect, volumes. We're gonna pick them all. Oops, sorry, pick all. XY plane. We hit OK, and then we have again our junction. Now we're gonna go to numbering controls, merge items, key points OK. So now, from now on, I'm gonna do the next steps quite faster because we already did them before. So element type, IDD, delete. Okay, 185. Okay, the material properties. We have already the material defined. So no, we don't. So we now have to anisotropic material 2.111, 0.3. Okay, the meshing dimension might be pre-established, but we're just gonna do it. Meshing, size controls, manual size, global size, 3 divided by 1000. Yeah, here volumes, with volumes, pico. This meshing is going to take longer because there's more elements. You can actually see what's happening if you open the Ansys output window. And we'll look at the model again. Very high quality meshing. Plot volumes. And I'm going to do a solution, define loads, apply displacements on areas. These, oh, here we have a little problem. Okay, I just realized that by using the cut, this creates a series of areas. So every time you want to apply something, you have to do it in more than one area. So we'll have to apply it on there. I'm gonna hit OK, all degrees of freedom, and we have to go to the other side and do basically the same. Okay, the same again. The next step is to apply the force. We're going to apply the structural force on key points. You can zoom in a little bit. We're going to apply one there and one there, minus 1000 on the y direction. And what's last is to go to solve, currentilize, OK. I'm going to pause it and be back when it's done. Okay, we have the solution is done, message. We go back, so general post-processing, read results, last set, plot results, nodal solution, degrees of freedom, vector summation plot. And we get pretty much the same results. The von Mises stress, we'll see, there might be some issues in there. Von Mises stress. It looks quite similar, looks pretty good actually. And I'm not going to show you the vector plot because it's very similar. So now you know. So now you know how to perform a more complex simulation with more functions utilizing volume type elements. I'm going to quit right now. And we would like to thank you for your attention, and we hope you enjoy this presentation. For more tutorials, please visit our community and follow us in the social media.